Okay, these are some application problems, and this is something similar to what I'm going to expect you to be able to do on the test. Okay, so I'm going to give you two vectors, no matter what the context of the problem is, and I'm probably going to ask you to find the resultant vector, which is what you get when you add the two vectors together. That's called the resultant vector, okay? And then probably ask you to find the magnitude and direction of the resultant, okay? So it's everything we've done so far. The only additional thing that we're going to have to do is draw the picture to figure out where the vectors are going. So that we get from reading the problem. Okay, and if you've had a physics class, you've probably done something similar to this before. It says two forces, we'll call it F1 and F2, of magnitude 70 and 50 pounds, respectively act on an object. So you have, if you look at this table here, you have one, maybe you have one force pushing on it this way, and one pushing on it this way. Where is the table going to end up going? Right? If this force is stronger, it's probably going to be more in this direction rather than this direction if this one's not as strong, right? Can you kind of picture that? Okay. So, let's see. It gives you information about both forces. It says the direction of force 1 is south, and you swing open 56 degrees. So this is force 1. This is the object that it's acting on. Think of that as the origin. And this is 56 degrees. However, I want to make sure, remember, your angle or your direction for your vector always needs to start at the positive x-axis. So I need to, when I find my component form, and I find my A and my B, I don't want to use 56 degrees. I want to use this angle. So force 1, what's that angle? How would I figure that out? Yeah, 270 plus 56. And yeah, you get 326 degrees. So that's the angle you want to use for force 1. So remember, you always want to use it, the direction should be starting at the positive x-axis. Okay, for force 2, let's see, force 2 comes up north, 72 east. So I start north and I swing open 72 degrees east. So I need to find this angle for force 2, right? Because you've got to see where you swing open from the positive x-axis. So how would I figure out what that second angle is? Yeah, 90 degrees minus 72 degrees. That's going to give me 18 degrees. Now, it says the magnitude are 70 and 50 pounds respectively. So the magnitude of force 1 is 70. The magnitude of force 2 is 50. Okay, the question says, find the magnitude to the nearest degree of a pound and find, or the nearest hundredth of a pound, and the direction angle to the nearest tenth of a degree of the resultant force. So the resultant force is what we get when we add those two together. Okay, so let's first find F1 plus F2. That will be our resultant force, is the F1 plus the F2. Okay, so for F1, to find my components for A and B, for F1, that would be 70 times cosine of 326 degrees, that will be I, plus 70 sine of 326 degrees, J. Right, that's my F1. Now I'm going to add that to my F2. My F2, the magnitude is 50, so I'm going to take 50 plus cosine. My degree is 18, so I'm going to take 18 degrees I plus 50 sine 18 degrees J. I'm going to add those two up. I add my i's and my j's. So put in your calculator 70 cosine 326 plus 50 cosine 18. This is what I got. You can double check and make sure I did it right because I kind of rushed through this last night. I got 105.6. God bless you. For I. And then when I added the B components, or your vertical components, I got, let's see, 23. Oops, that should be a negative. I got a negative 23.7 J. Is everybody getting the same thing?
Are we going to be given any of those formulas?
What formulas?
Like the like 1 half 1 equals the V cosine of
Well, I think what you're thinking of is just the component form. No, that you have to know, and you don't have to memorize that. That's just using SOHCAHTOA, right? Opposite over hypotenuse and adjacent over hypotenuse. Okay, so here's my resultant. So now I need to find the magnitude of my resultant. So I'm going to take 105.6 squared plus a negative 23.7 squared. And I put that in the calculator, I get 108.2 pounds. So that means if I have a vector of force, 50 pounds pushing this way, 70 pounds pushing this way, together they create a force of 108.2 pounds pushing it this way. Okay? Now to find my direction of that vector, I take my B, my vertical component, which is negative 23.7, over my horizontal component, which is 105.6. If I imagine, remember, I'm adding these two vectors together. If I imagine that I create my parallelogram, my resultant vector is going to come up in here somewhere. Let me do that in a different color. Let's see, I'll use blue maybe. My resultant vector should come up in here somewhere because I'm going to make my parallelogram and it's going to come up like this. So what quadrant should I be in? The fourth, right? So I want to make sure that my angle jives with the fourth quadrant. Okay, so when I put that in on my calculator, I'm going to get negative 12.6 degrees, which is the fourth quadrant, right? Because I open up in the negative direction, 12.6 degrees. So that works. I don't have to add pi to it or 180 degrees or anything to it to adjust it. However, we always want to put positive angles in standard position as our final answer. How can I write negative 12.6 degrees as my final answer in the positive standard position? So instead of opening backwards 12.6 degrees, I want to go counterclockwise in the positive direction.
347.4.
Yeah, 347.4 degrees. I would just add 360 to that to figure out what that angle is. So the direction of the force, when I add them together, force 1 and force 2, is going to be 347.4 degrees, and it's going to be with a force of 108.2 pounds. Everybody okay with that? Okay. It's a lot of work, but it's not that hard. The only thing that's tricky is making sure you're looking at the right quadrant. Okay, that's really the only thing that's tricky, is keeping track of that. Okay, last problem. This again is something similar to what I would ask on a test. And I'm only going to put like one of these on there because, I mean, we only have a limited amount of time. It says an airplane is heading north at an airspeed of 500 kilometers per hour. So north, directly north would be this. This is my plane. We'll call that vector P because that's my plane. The magnitude is 500. It's going 500 directly north. Okay. There's a wind blowing from the northwest at 50 kilometers per hour. Okay, coming in from the northwest, if it doesn't give you a specific degree, you can just say that it's at the 45-degree angle if it doesn't give you a specific degree. So here's the wind coming in from this direction. So this is 45 and this is 45. Okay, now, if we want our vector to be in standard position, though, we want it to be where the initial point is at the origin. So I'm just going to bump this down. It's still going to be the same direction and the same magnitude, but I'm going to put it down here instead so that it starts at 0, 0. So we'll call that vector W for the wind. And it says the wind is flying at 50 miles per hour. So my magnitude for the wind vector is 50. So I have the magnitude of P, the vector for the plane is 500. And I have the magnitude for the wind is 50, and that's in miles per hour, or sorry, kilometers per hour. What's my angle for vector P? Here's vector P here. Vector P, not wind. I'm sorry, what? 90, right. Okay, and then I think you set it for the wind, right? 315, since this is 45. If I write down the angle starting at the positive x-axis, if I swing open this way, that would be 315 degrees. Everybody follow why that's 315? Okay. So the wind is pushing on this plane. The plane wants to go north. So the wind is going to push the plane a little bit off course. So we want to see how far off course this plane is going to go so they can figure out their course correction so they can still head north. Okay, so we want to add the plane's vector and the wind vector together and see what that angle creates to see how far off direction it is. So I'm going to take P plus W and find my resultant vector. For P, I don't have a horizontal component, right? P is straight north. So I'm not going to have any I component for this. So it's just going to be 500, whoops, I want sine. Sine of 90 degrees J. That's my vector for the plane because I have no horizontal component. It's straight north. Now for the wind, I do have a horizontal component. My horizontal component for the wind would be my magnitude, which is 50 times cosine of the angle for the wind vector, which is 315. That's I. That's my horizontal component. And then my vertical component would be 50 sine of 315 degrees. And that would be J. Sorry, I'm running out of room there. Now this is standalone since I don't have another I to add it to, but I can combine the J's. When I put in for the I, when I put in 50 cosine 315, I get 35.355i if we round to 3 places. Plus, then when I put in my j, so in the calculator I'm going to put 500 sine 90 plus 500 sine 315. I'm going to put those in the calculator and add those up. And I'm going to get, when I do that, 464.645j. So this is my resultant vector. This is what I get when I add my plane vector and my w vector together. To find the plane speed, the speed is our magnitude. Okay, to find the plane speed after the wind pushes on it a little bit, right? So we add the plane speed plus the w, the wind speed. I'm going to do that by finding the magnitude of my resultant vector. So I'm going to take 35.355 squared plus 464.645 squared. Take the square root of it, and I'm going to get 465.99, and this is in kilometers per hour. So relative to the ground, this is what the plane is actually flying because the wind is slowing it down a little bit, pushing on it. Okay, now to find the direction after the wind pushes on it. Right now, we think the plane is going due north, but when the wind pushes on it a little bit, it's going to throw it off course. So let's see where the new course is with the wind. So I'm going to take inverse tangent. I'm going to take my vertical component, which is 464.645, over my horizontal component, which is 35.355. What quadrant should I be in? So my plane is going 500 this way and the wind is pushing on it this way. So I'm going to end up in here somewhere. If I imagine, if I scale this, I didn't scale this very well, but if I scaled it, if I came out only 50 this way and 500 this way, and I made my parallelogram, my plane plus wind vector would come up into the first quadrant. So I want to make sure I have a first quadrant angle. What did you get for the inverse of tangent?
85.644.
I got, do you need to round it to 5? Or did I make a mistake rounding? I got 85.65.
Yeah,
65, okay. I just want to make sure I rounded right. Okay, so the plane's direction, according to the instruments on the plane and the pilot, right, in the cockpit, saying it's going due north. But the wind's pushing on it, and so it's actually going at a 85.65 direction. So this is 85.65. So how do I figure out how much off course this plane is? Yeah, just subtract from 90. So I take 90 degrees minus 85.65, and it's 4.35 degrees off course. Is this okay? These are lengthy problems, but I don't think they're hard. They just take a while.
Do you think for the final you could give us this, since we already like, pretty much all know it, so we don't have to waste time filling it out?
I'll think about it. I'll think about it. Okay, any questions?